bonjour. This is the only word I'm going to use in French for the moment because we are an international symposium. So I would like to welcome you. The whole presentation will be given in English throughout the whole afternoon. If you are willing to ask questions and you are not really completely fluent in English and you're too shy to ask a question in English, you can of course ask me to translate, and I will be more than happy to do so. So you can ask the question in French, I will translate for our speakers, and then they'll give the answer. If you need a translation, I'll give the translation back. But the goal is to give this presentation completely in English from step 1 to step 2. So first of all, I would like to welcome you, a warm welcome for our first international symposium that is focused on cybersecurity and Internet of Things, which is today a real challenge because connecting all these objects to the network is generating today ways to hack your environment and have access to most of the data and elements that are on these Internet of Things. ESAIP, which is a graduate school of engineering, focuses on cybersecurity. And the region, the area we are in, has a national recognition of its speciality in Internet of Things. So when we created this topic, we had a partner, which is a very famous company in the field of automatic vehicles, which is Vector, and I would like to thank them. There is Jean-Philippe Dehaene, who is present. And thank you very much, and we have signed an agreement to finance for 3 years an academic chair in this field to make the knowledge in cybersecurity and Internet of Things evolve and to have everybody participate and exchange with their experience in this field. So we are launching this first international symposium within the Connected Week, which is a week that the agglomeration of Angers is going to organize every year. In fact, it is the goal of Angers is to federate all its ecosystem in this field and generate numerous activities within this and with an international environment. It is also the first year that Angers is hosting an international meeting of the top companies in the world in electronics, all the influencers, which is called the World Electronic Forum. Normally, this World Electronic Forum is a closed event. It is an event only for the CEOs that meet throughout the world. It has only been twice in Europe and once in France, in Angers. So it is something very exceptional, and this is a real teamwork. And so we have all decided, all the higher education systems, the companies, the ecosystem, our public powers and everything, public deciders have decided to organize within this full week a major event to promote our skills throughout the area, of course, through the national and international. As we have signed this academic chair, research chair with Vector, who wants to also move on these cybersecurity issues within the vehicle environment, we are going to have the first talk on this topic. And Jean-Philippe Dehaene, who is the CTO of Vector, which is a German company, but he'll probably talk a little bit about it later, and they are currently working on these issues for these automotive vehicles. So let's go directly to the topic, and I think Jean-Philippe will take over. Of course, around 20 minutes of talk, then 10 to 15 minutes of questions, okay? Do not hesitate within the phase of the questions to raise your hand so I can bring you the microphone so we can hear out clearly your question and then let the speaker give an answer, okay? The last element on the practical point of view, I would like you to please put your cell phones on a silent mode. And of course, you can connect through internet for the Wi-Fi with Symposium and ESAIP Cyber without the point, without the dot, I think. And you can also tweet for those who are connected on the different tweeters. So you've got Connected Week, Cybersecurity IoT at Group ESAIP. You can tweet throughout the presentation. So let's not wait too long. I'm really happy to launch the first speak. Please, Jean-Philippe Dehaene, after you. Thank you very much.
Thank you very much. Thank you very much, Christophe. So, oops, this is me. Okay, so good afternoon. I want to talk about automotive electronics this afternoon, and especially what is happening in what in the automotive world we call security. Security in French is a double word. It covers both safety and security, and I will talk about both because what is happening in automotive electronics is quite interesting those days, especially as we have this crazy idea that the vehicle could be more autonomous and drive instead of you. And this must be done safely and without also security issues. Oops. So I will introduce quickly the company and the topic, and then we will have a short look about functional safety, as we call it, and cybersecurity in this automotive electronic world. So, very short, Vector is a German group, now about 1,900 people worldwide, but German group, more than 1,000 people developing the products in Germany. And what we offer is tools and also embedded software to ease the development of embedded electronics, especially for the automotive market. So, 10 years ago, security was absolutely not an issue in this automotive world. I have just a little story about that. I was interviewed by a police officer. He managed a department, and he wanted, for some reasons I will not disclose, to hack some vehicles. And he asked, is there any security that I should overcome? And I told him, oh, I was even surprised by the question. I told him, no, we just designed this electronic to work. That's all. So, however, 10 years ago, there was already a large part of electronics in our vehicles for comfort, for engine, for suspension, steering, and so on. And some of these functions already need to be developed with safety requirements. But this was more done on an individual basis and with individual expertise of the different tier ones and OEMs. There was no rules at that time regarding that. And also the vehicle was a closed world, only one external connection, so-called for some people, the OBD connector, so onboard diagnostics, is the standardized connector which gives access to diagnostic features for the vehicle in the garage and also for law enforcement regarding pollution. But that was all. Also, this is the solution which was already developed at that time to reprogram some functions of the vehicles. Some of the ECU, as we call them, so electronic control units, were not reprogrammable, but nowadays, more and more, all control units have more and more software, and so possibly more and more bugs. They need to be updated. So now, things have evolved and are still evolving. The vehicle becomes part of the IoT, Internet of Things. It becomes connected by many, many channels, whether it is for infotainment, whether it is for updates to bring new features. With Tesla, you can even buy new features online. Whether it is the other way to bring back data to the OEM, for example, for preventive maintenance or whatever. So both by its connection, but also by its features, this car becomes with more and more features, yes, and also in the domain of what we call autonomous driving. So it started with assistance functions, and now more and more we have this idea to have so-called autonomous vehicles. So this brings me to functional safety. As I said, the first work in these domains, for example, for electronic gearbox or for engine control, were based on individual knowledge by some people moving from aerospace to automotive electronics, for example, also by industrial standards. But none of these standards and way of working were really appropriate for automotive. So finally, OEMs, automotive OEMs and automotive tier ones came together in the frame of ISO work group to build this ISO 26262 standard, which covers what we call functional safety, which defines some so-called automotive safety integrity levels, the D level, A, B, C, D, the D level being the highest one. This is not as safe as aerospace, for example, but it was, let's say, the first step to bring safety into the vehicle. What we shall say also compared to aerospace is that there is no law enforcement of any safety standards. There is no regulation that says you should apply these standards. But on the other hand, automotive is a volume market, and if there is a failure, there may be hundreds or thousands of dead people. And so by itself, the industry, and maybe also pushed by the tendency, for example, in the US, to have every time laws and, I don't know how to say it, the court, there is to go to court and so on. So the industry by itself appropriates these standards and use it, because now it is a state of the art you cannot ignore. So even if it's not enforced by law, you must apply it, else you take very big, let's say, business risks. Oops. Okay. Yes, we are still at that time of this first version of the ISO 262 standard. We are still at the level of what we call fail-safe features. Typically, we are calling about, for example, a steering assistance function. If it fails, okay, you need your muscles, but you can still steer the vehicle. Same for braking assistance. You have still the mechanical possibility or the hydraulic possibility to brake, even if the electronic assistance disappears. And so the industry took these standards and developed solutions. At Vector, we are providing basic software, so the kind of operating system for the electronic control units, and we developed a full solution for this basic software, which is qualified to the AZD level. So it allows the tier ones and the OEMs to develop a vehicle and functions at this AZD level. What is not yet covered or cannot be covered at this individual software level is the next step, I would say, which is needed by the autonomous vehicle. It's what we call fail operational. If the vehicle is autonomous and is driving by itself, but there is a failure, the driver is not instantly able to take over the steering wheel, and so you need to still be, the vehicle still need to be operational and to, for example, safely park on the side or something like that. So functions need still to be operational, and this is a further step that will be covered maybe by ECU redundancies or things like that. Okay, so whether we are fail-safe or fail operational, there is an important thing, is that if you have developed functions with safety requirements and safety qualification and even certification, but a hacker can come in and reprogram your ECU and change parameters, for example, you are lost. So we say that you cannot offer such a safe function just based on functional safety, but we realized that we need also to cover the security part to be sure that the function that has been designed to work safely cannot be maliciously act to a malfunction point, let's say. So safety, that's what we say in this automotive world, no safety without security. So we developed safety first. Let's say it was the past 8 years, 7 years. And now there is a new focus. Some of them call this a fame, but I don't think it is the case. There is a new focus to say, okay, now we ensure functional safety, we have to also ensure security. And this awareness also comes from many recent exploits, which are mostly still at the, let's say, university or research level, hopefully. But just Googling car hacking give you already to many hints what's happening in our world in the past years. Some Jeep Cherokee has been hacked by connected ECU, and as the vehicle becomes autonomous, it's not an assistance, for example, for the steering wheel, but there is an ECU that is able to steer the vehicle by itself. And so if you are able to take control over it, you are able to put the vehicle on the side. I think it's this picture here. There has been some demonstration on Toyota Prius as well. It was physical hacking through the diagnostic ports in that case. There has been, yes, many examples that has been published in the past years. And so awareness in our automotive electronic industry is rising a lot. And that's why this interest for cybersecurity, particularly also from Vector. Also, as I have already shown this picture, the fact that the vehicle is more and more connected by many ports opens many attack vectors. So in the past, it was only you needed to have access to the CAN bus, for example, either through the OBD plug or even by opening the hood and cutting wires. Okay. Or our police officer I mentioned previously had other ideas. But now with wireless access, you can even go further. And typically that's what was done on the Jeep Cherokee. They went through communication ECU. So, as we did for functional safety, there is a rising topic, let's say, in this automotive electronic world. Should we also develop a standardization for security? Some people say, oh no, security, it's a secret topic. I better work on my side and hide everything, and I will be secured. But many others, particularly, there was a dedicated presentation by a Daimler guy, are asking for, let's say, a share of the knowledge and the construction of a global solution, and so an automotive standardization. The US people fired first with this SAE. SAE is the American Automotive Electronic Society. So they released the first J3061 standard, let's say, or proposed these standards. But the German side do not agree so much, and now they are discussing to create an ISO work group to further develop an automotive security engineering standard. So which will be also, which will, let's say, answer or complete the functional safety part, where a second version should be prepared soon to cover higher level of risk. With ASIL-D, as I mentioned, we were at fail-safe level. Now we have to go further to fail operational, and so the ISO 26262 standard will be developed as well. So there is this standardization, which is starting really. Automotive, as I mentioned, is in the ramp-up phase for this security topic. But it goes, in this industry, the cycles are short. Typically, for the electronic, it takes 2-3 years to be developed. And so the solutions are quickly, the first solution, let's say, are quickly put in place or enhanced progressively. And so there is a lessons learned curve which rises very quickly. So, for example, in future architecture, we are discussing to have typically gateways and firewalls inside these gateways to reinforce what we call the security access by higher cryptography level, to reinforce software downloads by signatures, or even by encrypting the program flow. Inside the vehicle, to avoid that some people goes inside and cut some cable and okay, first of all, listen to what is going on between the issues. We imagine not to encrypt those communication, because of course this needs CPU power or specific hardware devices, but at least to sign the communication to avoid replay attacks or to avoid intrusions in these inside networks. So we are participating with our basic software solution. We are participating to those IDs. we develop standard modules that will help to make our vehicles more secure in the future. This is also a very big challenge for the other part of Vector, the part which is developing tools that we develop for almost 30 years now to help, for example, to test the vehicle. And for this, for example, we have data loggers that log what happened on a bus. And if you have discovered an issue, you want to replay your log and to check that you have correctly corrected this issue. But with anti-replay security feature, how do you do that? So that's my, oops, next slide. So security is really a challenge also for testing. There are two topics, and I recently had a meeting at a French OEM where he has exactly the same vision. There is the topic, of course, of testing the security itself. Security, it's a new feature that we add, and we want to test it. But there are special test methods in this field. I listed some of them. At Vector, we have a research project that is focusing on to complete our testing tool by fuzzing, so which is somehow to intelligently simultaneously with randomly replay protocols to try to attack, for example, the diagnostic protocol or stuff like that. But the second topic is also very important. We still want to test the normal feature of the car. We still want to be able to replay these logs that we have recorded. And so the topic testing despite security is also very important. But as each car manufacturer, at least in the first time, will develop specific solution, we need to find a specific solution for each car manufacturer to somehow get the keys of the car. And so we developed a kind of security manager which can securely connect to the different car manufacturer solutions and allow our tools to be accepted in the network like another normal ECU, and then to replace those logs, for example. So these are the topics which are currently occurring in this automotive industry, and I will be glad to answer to your question now if you have some.
Who would like to start with the first question? It's always the hardest. Yes.
Thank you. Introduce yourself, please. Jean-Paul Béchu, CEO of Nameshield and Brandsays. As we are specialized in DNS, I would like to ask you the following question: what do you think about the future of DNS related to IoTs?
Mm-hmm. DNS, domain name server, am I right? That's correct. Yeah, okay. So first of all, I have to say that in this automotive electronic world, currently we have no such features, as we are a closed world with specific buses like CAN bus. But there is a recent evolution also to introduce Ethernet in the vehicle, and there are different approaches by different OEMs how to build this Ethernet communication architecture in the vehicle. Some of them are purely static architecture, so still no issue of name resolution. Others are dynamic architecture, and then maybe we'll need some feature like that. And there is also, of course, the connection to the outside world of the vehicle, where there are such requests. I don't know how to secure it myself. I'm not expert enough. I can tell you that for the inside of the vehicle, IPv4 is still very largely used. For the outside, as we discussed, there is now more and more the idea that we will have so many objects that we need many addresses, so IPv6 will be used. But how this is precisely secured in the details, I'm not able to answer, sorry.
Okay, thank you, Jean-Philippe. Are there any other questions? Just before you ask your question, can you introduce yourself? We can know who you are, and then you can go for the question.
Okay. My name is Ajit. Here I am doing Masters in Security Science. Actually, I am from India, and I want to ask you about What about the operating system? Which kind of embedded software are you using inside automatic vehicle?
Inside the automated vehicle, what type of software?
What type of operating system?
Of operating system, okay. In the automotive world, there has been, since the past 10 years, there has been a standardization called AUTOSAR, which defines somehow a middleware for the automotive ECUs, for the electronic control units. And so this middleware includes communication on the different buses, CAN, LIN, and Ethernet buses, as well as a real-time operating system with preemption. So we developed this for the past 10 years, and we call this AUTOSAR at that time. And now, since, let's say, 2 or 3 years, there is a new tendency to say, okay, this AUTOSAR you knew, it's called AUTOSAR Classic. It's already obsolete. No, not really, but it's classic. And there is a second type of AUTOSAR which is coming, which is called AUTOSAR Adaptive. And in this second case, it's based on POSIX operating system, so such as Linux, QNX, Integrity, and with dynamic configuration feature, dynamic link libraries possibilities, and so on. But in the past, let's say it was a purely static and embedded real-time operating system.
Okay, thank you. Are there any other questions? Yes.
Hello, I'm Olivier Mergier from ESAIP. I've got a question rather about the road and people trying to hacking like the traffic light or the signs rather than the vehicle. What can we do to that?
Mm-hmm. Yeah, good question. Even more interesting question, because not only there are the signs themselves which can somehow be read by the automotive cameras, for example, but also there is a new technology that comes up slowly, which is called, for example, vehicle to vehicle or vehicle to infrastructure. And in that case, the vehicle gets the information directly from the traffic light and not by the camera. But whether it is optical or whether it is electronic, it could be hacked in both cases. Again, I'm not the expert. I imagine we could introduce some plausibility checks if the inputs are inconsistent with other context information, for example. But that's my first idea that comes to suit. Sorry.
Okay, thank you. Waldemar has a question from one of our partner universities in Poland.
Thank you. May I have a question about regulations or agreements between your company and car industry? For how many years you should purchase your systems? For example, if there are any security issues. I mean, for example, given by your the example with the car which was hacked by someone. Are there any regulations between your company and car industry, and for how many years you should apply any patches for the software and so on?
There is no regulation. Typically, what we propose, but it was not specifically related to security. It was also at the beginning related purely to quality. Typically, we offer 2 years warranty on our embedded software. We offer also every 2 months. We run a huge script which capitalize all the issues we have collected from the field on different versions of our operating system distributed to different tier 1s, OEMs, vehicles running in the world. And we inform the other owner of our licenses, okay, we have detected an issue in this module, you should check it, maybe you are impacted, there is maybe this workaround. You should maybe update to this version to be able to correct it. And we do this over 10 years. This is our current policy. Maybe this should be extended based on a consideration like safety and security in the future. Yeah.
Okay, thank you. You have any other questions? I would have 2 questions, Jean-Philippe, if it's possible. Sorry, one easy one. We will not repeat your answer outside, but is it easy today to hack a car?
Today, I would say with today's cars in the street, as I said to the police officer 10 years ago, mostly there has not been many protections imagined. Maybe only on some features, like keys, but it shouldn't be so difficult, especially if you have access to the wires.
Yes, exactly. So it's quite easy to hack a car, and is it easy to hack a very high standard car, high quality car, or is it more difficult? I'd say major brands that have in their baseline that the security is first.
The issue is that, to answer honestly, the car manufacturer, let's take a French one, they have both very low-end and low-cost cars and also higher-cost cars, but they are developed with the same technology. Okay, and it's the same even. Okay, there are in the world like the German car manufacturer have a high reputation, but I think they are ahead of all others in the electronic technology for their cars. But however, security is a recent awareness, and so they are maybe a little bit more ahead, but not so much.
Okay, thank you. And my second question, and then if there's other questions coming up, I'll give the elements. The second question is related to the approach. You gave us a presentation on Vector's approach, saying that it is today a very hot topic for Vector and in the vehicle environment to start working on security. We saw also that there's a lot of challenges to overcome today. What do you think about an approach that would be using hacking techniques to secure better the car? Do you apply these techniques today in Vector, or are you planning to do it? I think you talked about the fuzzy approach and things like that. What do you think about the approach of, we believe, ESAIP, Graduate School of Computer Science, of Engineering, that the approach of being outside the system and hacking it, it's the best approach to secure it better. What do you think about this topic?
So at Vector, the main entity is the product lines. They develop products and they enhance it years after years. And in that case, it's more based on requirements or identifying a need, and you develop something. But we have also created those research, advanced study departments where we study alternative ideas or new topics, and typically for these departments, and I think that I'm not in their deepest secrets, but I think typically this is what they do in this fuzzing project.
Okay, great,
and
thank you.
Maybe the last part of the answer is that also we are at the service of our OEMs and tier ones, and so it's also with them, or it is maybe their task also to do such approach.
Okay.
And we provide the tools.
Okay. Of course, with an ethical approach. The hackers are not there to destroy, they are there to do it ethically. Do you have any other questions? Yes?
Good afternoon. My name is Anand. I come from India, southern part of India. Actually, I have one question. Could you please explain us the methodology that you're using to pen test a car, connected car? And if you find a bug in the car, how do you fix it?
Okay, I think the methodology is quite classic. Let's say at the base of it, it's always a small v. You need to define your need, to design it, to implement it, and to test it. Okay. Now, what is new in our methodology for embedded software is that we put this in these little v's in agile mode, and so we are able to react more quickly to new demands and to introduce an increment, as we call it. More rapidly in the market, at least on the beta version, and then to globally test it completely in a later stage. So we have such a methodology. And to correct bugs, we create issues in an issue tracking tool, and so there are analysis, what is the root cause, and correction and test of this correction. I would say this is classical software engineering since years.
Okay, thank you. Do you have any other questions? Just if I've understood correctly, the conclusion is that in fact the automotive environment, the vehicle environment is going closer and closer to the network environment, because if we understand the networks were closed and they're getting more and more open, and probably tomorrow it will be internet, the technology used. So
networks are in the root of a vector.
Yeah.
We born with the CAN bus, but now it's more, let's say, classical networks, like especially Ethernet. And there are some specific automotive Ethernet protocols, but the roots are the same as for the classical Ethernet, TCP/IP typically. Okay. And so we have also to learn this new world.
Okay. Okay, thank you very much, Jean-Philippe. Without waiting, we're going to go to the second talk. Invite Ramón, Durán, Barroso to join me. He's an associate professor and deputy director of a very well-known institution in Spain, ETS, the University of Valladolid, as you know, in Spain. And he's going to give us a full presentation. I'll give you the slides up. Let's just swip on enabling technologies for IoTs and the new trends in future communication networks. Have a nice presentation.
Well, cool. Thank you, and thank you for the invitation.
Just going to swap the microphone. This one works better. Up, there you go.
Here? Yes. So thank you for the invitation to attend this symposium. Well, as the director said, my name is Ramón Durán, and I am the associate professor at the University of Valladolid in Spain. We are quite close to Madrid. So, well, when I was invited, and I think, well, what can I say? Okay, well, the problem here is that the new emerging paradigms, for example, IoT, but also tactile internet, Industry 4.0, require or impose restringent requirements in current network, and current network cannot provide these requirements. So, okay, my idea of this talk is to briefly introduce some new technique. Probably some of them are new for you, but I'm going to introduce it very briefly. That will be combined with the current one in order to provide or to deploy IoT services. So my talk is divided in two parts. The first part is related with networks. The second part is related to network, and the second part is related to control protocols and also to computing. So in network, we are going to have a lot of consistent technologies together with the current ones. For example, 4G, Wi-Fi, GPON, EPON, wavelength routed optical network. Perhaps you know that, well, we are currently using all of them, but we are going to have another technologies. So I think that probably in the front haul network, together with, for example, 4G, Wi-Fi, and GPON and EPON, the apparition of the appearance of these technologies is going to be the future. It's low power one, 5G, Li-Fi, and sorry, I don't know if I'm in the middle, and the new generation of passive optical network. More capacity when I go down, more mobility as I go up. It's the front haul network, so it is the part of the network near the user, and they are based on radio or optical. And in the backhaul network, we are going to have, or we are going only to trust in optical network from our point of view. And we are going to see, well, some evolutions and research that we are making in elastic and multi-core fiber optical network. And in the second part, is here? In the second part of the talk, I'm going to talk about computing and control technologies. I think that for sure you probably know what is software-defined network, but also virtualization of network function and cloud, fog, and MEC, that is mobile edge computing. So new services require more capacity, so we have to improve the network and also to put more computing power in the network, but also they require to reduce the latency. And to reduce the latency, we have to improve the network, but making that these computing resources move them closer to the user. And the key issue here is the heterogeneity of technologies that we are going to have in the future network. So, well, all of you know what is IoT. IoT consists of a vast number of interconnected devices, all of them heterogeneous, wearables, smart home appliances, medical devices, automobiles, Okay, so it is expected by 2020 from 20 to 46 billion of devices connected to the network. It is a lot. So, well, let's start with the technologies. The first one is low power wide area networks. The key idea in this technology is to have, provide a network, okay, that's with a very low power consumption. So, if, for example, imagine that I want to put a sensor, and I put a sensor inside, well, in the middle of a mountain, and testing the temperature every month, for example. Well, so we have low power, so the battery life is a lot of battery life, but the idea is that we are going to have very low bandwidth. So, in fact, it is not good, for example, for a mobile, but for some application could be very interesting. The thing is that we have a wide range and coverage. It requires low number of base stations, and the cost is very cheap. There are different alternatives already in the market. For example, Sigfox and LoRaWAN are already in the market, are RPMA and HCLTH also. Well, the last one under investigation, research. The second technology that I envision is, well, the 5G generation of mobile network. It is now under research, under definition, and under standardization. So it is only more or less it's research and definition, in fact. Okay. As you can see, we have one generation per 10 years, more or less. So it's in this 5th generation, the most important things is not only to improve the higher bit rate. For example, they are defining a bit rate until 1 gigabit per second, but in fact, 4G generation also provides this capacity, this peak capacity. But the idea is, okay, we are going to do that, but for more devices, reducing the latency, reducing the energy consumption, reducing the cost. So this is the idea of a 5G network. So it is not only to allow higher bit rate, but fulfilling all of the other indicators. Well, at home, together or inside an office, together with Wi-Fi, we are going to have the new technology that is going to appear is Li-Fi. It's similar to Wi-Fi. The idea is similar, but it is not based on radio frequency, but based on light. It's visible light communication. So light is also a radio frequency signal, but with a very, very high frequency, centering a very, very high frequency. So the bandwidth is very high also. So we can provide with Li-Fi high capacity. Regard that the speed is more than 1 gigabit per second, while current Wi-Fi system offers, well, a bit more than 100 megabit per second. The idea is to switch off the light very fast, to modulate the light very fast. It is not visible for human eyes, but it is good if I want to transmit different signals. And well, application obviously indoor, in office, in homes, but also in vehicles for the communication with the front and the rear light to communicate one car with other cars. I think I saw some applications with that. It is not Li-Fi, but it is also based in visible light communication. So, and then moving toward more and more capacity, the access network with more capacity that we have now, the fiber to the home, is based on passive optical network. The idea is that we only have passive equipment in the distribution network, so it is cheap. It is now we have currently two different standards, GPON and EPON. It depends on the country and depends on the operator. Here in France, similar than in Spain, most of operators, I think all of them, in fact, use GPON, like in America. But in Japan, the standard is EPON. use TDMA, and the capacity that they provide is 1 gigabit per second per shared. Well, in the evolution of this network, firstly, the first evolution are going to provide not 1, but 10 gigabit per second shared. It's similar to them. It's also based in TDMA, so in access based on time, and, but offers 10 gigabit per second. The second one, the second evolution, is you use not only the time, but also the wavelength in order to improve the capacity of the network. And we are going to achieve until 40 gigabit per second, and well, the 30 gigabit per second is more than under research, and a lot of people think that it's going to be based on OFDM. This is in the context of front-haul network, but in the context of back-haul network, so in the core of the network, in the transport network, we are going to continue using optical networks. Currently, we use wavelength-routed optical networks that are based on circuit switching. Its circuit is a iPad, and they use the WDM, the wavelength division multiplexing, in order to exploit the capacity of the routing. So, well, we establish different circuits, as you can see here. Okay. Okay. What's the next evolution of this network? First one is use elastic optical network. There are networks that use OFDM or Nyquist WDM techniques, these modulation techniques, in order to provide exactly the capacity that the user demands. And in that way, we are going to use the network or the bandwidth of the fiber more efficiently. And we will be able to provide more capacity to that network. The second one is to apply cognitive technique, either big data processing or in artificial intelligence inside the control of that network in order to improve the capacity, CAPEX, OPEX, you know, that are cost, both of them, and energy consumption. And the last one, the last evolution that are currently under research is the use of SDM, that it is using multi-core fibers, so fibers with not one core, but many cores inside. Now there are some experiments with 30 cores available. In that way, we are going to improve and increment the capacity of the fiber. As you have seen, all of this technology are going to be combined with the ones that we are currently in use: 3G, 4G, Wi-Fi. Okay, so we have a high level of heterogeneity. And how to deal with this high level of heterogeneity? Why? Using a very good control protocol, okay? Control plane, efficient control plane. And well, it is seen that probably SDN, software-defined network, is the best alternative to establish the future control protocol. The idea is to abstract the network infrastructure from applications, so decouple the network plane and the data plane. These SDN networks trusting a control intelligence logically centralized in a device, and this device is called the SDN controller or SDN orchestrator. Sometimes it received these both names. And well, there are some protocols already developed for this kind of network. OpenFlow is the standard, more or less, is the most used one. So thanks to use software-defined network, we can control and manage heterogeneous network devices and technologies. But it is quite good. And thanks to the use of this SDN network, we are going to obtain rapid innovation, even supporting third-party application. For example, I'm going to buy a router of Cisco, but about the router of Cisco, I'm going to run an application of a local company. That is good. Okay, it's more open, so we will have more markets, new actors in the market. Multiple vendors, multi-layer control, multi-tenancy, and with all of that, what we are going to obtain is to improve the quality of experience. Well, the virtualization of network function, okay, network function virtualization. It's allowed the implementation of services. Okay, they are very, and now currently operators are very interested in this technology. very interested in that. And they are pushing very hard for it. They allow the implementation of network services or virtual network function, that is VNF, on a standard commodity device. So, such as, for example, a server. The idea is, okay, now in core network, for example, I have a device that this is a firewall, very expensive, very difficult to manage. The idea is, okay, why don't we use a simple server and virtualize this server and install inside a firewall machine? That's all. And if I need a firewall machine in another place, I only have to virtually move to another place. That's all. So this is flexibility, another time open, is cheaper. This is the idea. So, well, this is the advantage of network function virtualization. Deployment of it will allow the deployment of new services. It's dynamic, flexible, reduce the cost, okay, reduce the time to market. So it's quite good. That's why the operators are pushing very hard for this technology now. And in the area of computing, well, all of us know what is cloud. Cloud is not a new topic today. Okay, it's, well, use ubiquitous access to resource application and service via internet. As you know, these allow rapid deployment, simple clients, a cost reduction. So for IoT is perfect. Okay, but have two main problems. The problem is, one, we are requiring bigger and bigger and bigger data centers. Sometimes we have to stop. And the second one is the high latency. There are some applications that do not allow us to do something, to go to a data center in US and come back. Okay, for example, tactile internet application. So how do I going to deal with these two problems? The first one is MEC technologies, mobile edge computing. The idea is to move these computing resources not in the cloud. Also, we have, obviously, the data centers, but also near to the user. Where? In the mobile edge, in the edge of mobile network. I put there some multipurpose IT hardware, so servers in that area, and with that, we are going to reduce the latency, and data centers are going to be smaller. So this is good for IoT, good for tactile internet. The technology that I showed you before, NFV, so the virtualization, requires this technology, the require MEC. And the group 5GPP, that it is in now the group in charge of the research of 5G development, recognize MEC as a key technology to deploy this 5G. And well, as it is a mix between cloud and network, computing, but also network is very important because we are going to have a lot of computing centers, each one in one edge of the mobile network. Okay, we need a control, a very efficient control, and this efficient control can be provided by SDN. And the last one topic that I'm going to talk is about fog computing. Say, okay, let's move these computing resources closer to the user. So, for example, to different for example, traffic lights, street lamp, buses, okay? And it is fog computing. It's called fog computing. Obviously, it establishes a level of hierarchy, different fog verticals, levels, from fog to the cloud, okay, passing through MEC. And some application, for example, if I have an application that's in which latency is essential, I'm going to use this fog computing or MEC computing. But if I only want to download a video, I can use cloud computing because it is more important. Latency is not also important. So, well, and similarly as in MEC, we need a SDN orchestrator. And, well, fog and MEC are not going to replace the cloud, but they will complement it. So in conclusion, the deployment of IoT, tactile internet, and Industry 4.0 requires new networks and new computing technologies. Some of them are presented here. This new technology are going to open the network. New market model are going to appear, new actors. We are going to have a reduction on cost, and also we are going to be more green, so less power consumption. We are going to reduce the power consumption. And here the problem is the heterogeneity of technologies at the same time. Technologies in the front hall, in the back hall, okay, combined now with computing resources, so it is quite difficult. And obviously, as everything is based on network, the cybersecurity, that it is the other topic of this symposium, is essential. So thank you very much. I hope not to... I want to talk about many things, and today I discovered that well, 20 minutes is not too much. But if you want, I can talk more about any technology you want. So thank you for the question.
Okay, thank you very much, Ramón. Do you have any questions? I will start with the first question then.
Perfect.
That is my goal. I would like to have a little bit more information regarding the FOG network. Do you think that the challenges in terms of security are the same as the cloud environment, or are they more important? And what kind of challenges do you spot out on these type of technologies?
Okay. The problem with fog and cybersecurity, the problem is that, okay, if in cloud I have a very specific devices sometimes in data center that I can do a firewall, and I can have many restrictions, but so I have many computing resources there. But the problem with fog and cybersecurity is that the computing resources placed in this node near the user are very limited. So this is a problem that should be solved. Okay. I think it's essential. For some applications are, for example, in tactile internet, the idea is that you have applications that have very low latency to add very fast in the network. So it is. Okay.
So the challenge is more related to the device that is holding the system than the technologies that we can have. You also pointed out something that's quite interesting. There's also a green approach challenge, meaning it probably joins what you said about the devices that they can't implement. We can't implement all the solutions that we want, so we have to always make sure that this device can hold the solution that's implemented. You talked about a challenge around green IT. Can you tell us a little bit more about this?
Yes, of course. Well, this is one of the main topics of research today. Well, I'm coming from networks, from network area, and this is one of the main topics today. How to reduce? I'm not sure, but I think that IT equipment contribute to the power consumption of all of the world about around 10%, 7 to 10%. So it is a lot of power consumption.
Of the traffic airline in terms of pollution.
Yes. So as much as we can reduce the power consumption, we are going to reduce the emission of the emission to the atmosphere. And well, there are some different alternatives. But now under research, all of the technologies, in optical technologies, in wireless, in 5G generation, the idea is how to reduce this. In the past, it's not a problem, or is it not seen as a problem because the problem is there. But now it's something very, very important.
Okay. And more we secure these networks, more it is electrical in terms of consumption. It consumes more electricity.
Or not. Sometimes, if you don't allow to run some malware application in some of your computing resources, you are also decreasing the electricity you. So, as the idea is, as better you design the network, as better you design your computing resources, as better you design the application in terms of obviously cybersecurity, but also the performance, the best power consumption you are going to obtain, obviously.
Okay, thank you. Do you have any questions?
Thank you for your presentation, Eric Lerouge, consultant. You mentioned the heterogeneity of different technology. That means that the architecture will be very difficult to set up. So first question is, as we are in a school, what the knowing will be necessary to set up such an architecture? And to come back on a security subject.
Which architecture?
With the architecture.
Oh, the
yes.
holistic one.
So it will be necessary to think about the complexity at the different levels.
Wow.
And the second point is about security. We can see that different technology will be based on, I suppose, different standards. What is the different approaches to make an architecture to be sure that it's as secure as possible, and all the steps are taken are really taken into account with their specificity?
Okay. Starting from the first question is quite difficult because we are combining many technologies, and obviously depending on what the user wants or the application that you want, you are going to use one or other. Okay. Yes. Obviously, for example, if we are planning a city, as you say. Obviously, you think that the backbone is going to be optical because of the flexibility and the high capacity mainly. So you assure that it's going to be optical. But what operators make is that try to use the cheapest technology as possible, but with the technology that can provide the requirement that the user wants. But it's difficult to say how to develop, because depending on the application, it's depending on the technology that you have. And regarding the second question, the security, well, it is supposed that when all of these technologies, some of them are under research, as I say, as 5G is going to be, or to have a standard in the future. Not today, but in the future is going to be a standard, because we are trying that all of these technologies are open, so it is easier for a company to enter in the market. And well, as long as the standard is fulfilled, the security problem should be minimized, theoretically.
Okay, thank you. Waldemar has another question, please.
Thank you for a very informative and interesting presentation. If we could shortly compare this Li-Fi technology with Wi-Fi technology in the context of the security, okay?
Li-Fi with Wi-Fi?
Yeah.
Well, thank you. Well, one of the advantages of Li-Fi, they say, is that Li-Fi is very easy. For example, if we provide Li-Fi in this room, and if we close windows, no radiation is going to, because it's light, no light is going to be outside. So anyone that it is in the door is not going to receive nothing. No one is going can connect to our network. So it is more secure than that. The problem is the problem with the Li-Fi is the technology. Currently, the studies and the research that it is done about Li-Fi is the technology. How to align the source and mobile, how to deal with the movement, because it is more difficult for light, because you have to have a direct vision, and in Wi-Fi not. So this is the main research area today. But it is a very promising technology.
It is a very promising technology, and he's playing with me. So it's a very promising technology, and it solves one of the elements, that is getting hacked from outside the house. Because if it stops within the building, then it's more secure.
Yes, for sure.
Any questions? Other questions? Or comment? Claire, you wanted to give a comment? No? Okay. Any other quick questions? I would like to just bounce on the question from our consultant that said the architectures and the main challenge is going to be related to heterogeneity of the networks. This is a real challenge. And the main challenge that I would think is that some of these networks were not thought at the beginning when they were created to be secured. Some of these technology. I'm going to think about the industry. We're going to have a presentation in a couple of minutes about the industry environment. Some of these technologies, when they were created, they were created to be closed from outside, so they were not secured.
Yes.
So I would think that the main challenge is trying implementing and hosting technologies that you have talked about that will be thought and created to be secured, and networks that are not at all. Do you think this is a challenge today, or do you think that these networks that are not secured will disappear very quickly?
Oh.
Not easy.
Not easy, no?
Yeah.
Well, maybe not. The thing with the security is that, well, we can always implement protocols upper this network in order to make these technologies safer and secure. I think that those networks that are not, well, when they were developed, or when we researched in the past about it and we developed it, and not secure, can be updated. But the best thing now is, well, to use protocol up this network in order to make it secure. For example, I think today, well, last week, WPA2 of Wi-Fi is vulnerable. We say that it have security problems. But the idea is okay if you but if you use security protocols upper this network, you are protected, so you are not going to have any problem with that.
Okay, thank you, Ramón. Any other questions? Okay, thank you very much for your presentation. I'm going to call Alfonso Bahillo, if I pronounce correctly, who comes also from Spain, one of our universities next to Bilbao. He's going to, excuse me, I'm just going to swap. You are going to talk about challenges related to a responsible approach with IoT, because your topic will be on cooperative location networks for handicapped people. Thank you very much, Alfonso, and have a nice presentation.
Yeah, thank you. Good afternoon, everyone, and thank you for coming. It's for me a pleasure to be here and have the opportunity to show you the preliminary results of an ongoing applied research project developed by DeustoTech in collaboration with the Intras Foundation. And this could be a good example of the Internet of Things applied to the location-based solutions in the context of handicapped people. Just a few lines for those who don't know anything about DeustoTech. DeustoTech is a research institute linked to the Faculty of Engineering at the University of Deusto in Bilbao, Spain. We are around 120 people aiming at developing solutions for the society and the industry under the umbrella of the ICTs. And the Intras Foundation is a non-profit enterprise from Castilla y León. It's a region also in Spain, aiming at improving the quality of life of handicapped people. Bluecare is a project which main idea is to create safe or secure spaces or places within which to monitor the position, the physical activity, the heart rate, and the temperature of handicapped people at low cost. This is more or less the main idea of this project. Well, yeah, there are two main motivations under this project. The first one is the fact that the dependents, such as children, elderly people, or disabled people, usually get lost in the public spaces. and as dependents, they don't have the skills to protect themselves. And the professionals, the family, the carers cannot keep their sights all of the time on them. Just two statistics. According to the study on missing children from the European Commission, on average, 400 out of every 100,000 children were reported missing within the last 4 years. And on the other side, in this case in Spain, there are annually reported around 16,000 disappearances. Half of them over 65 years. So they need a solution for tracking the position of them in real time, just to know where they are and if they are safe or not. The other main motivation is the need from the professional perspective and in the context of cognitive impaired people, the need to know the physical activity of those people, because this could trigger some warnings about bad situations. I mean, if a cognitive impaired people reduce their physical activity or modify their daily activity, the professionals interpret that as some change in their behavior, which get them go bad. So once again, we need, in this case, a solution which help the professionals to know the daily activity of those cognitive impaired people. As far as we know, currently there are more or less 4 kinds of solutions. In the upper left, we have GNSS and GSM-based solutions. They provide you, well, the disabled or the children or the dependents with a bracelet with a GNSS technology to know the location of the user, and with a GSM modem to send the information to the cloud. Well, this solution costs around 100 euros, and they don't work inside buildings. I mean, in those areas where you cannot get the GNSS signal. On the other side, in the upper right, there are some solutions based on the smartphone, some applications. Those solutions try to process all the information collected by the smartphone, well, by the sensors integrated into the smartphone. However, well, the price depends on the business of the company, and most of them doesn't work properly indoors, and well, not all the disabled people or the dependents or the children can carry a smartphone with them. And the solutions at the bottom, on the right bottom, they are based on contactless technology, which only can be read at few centimeters. So the coverage is quite few. And on the other side, on the bottom to the left, there are solutions based on BD codes, which are not, well, it has no sense in terms of coverage of the information. So what we propose is a combination of bracelet and gateways, which integrates a low-cost technology like Bluetooth, low energy, Wi-Fi, and Zigbee, aiming at creating secure spaces, places within which monitor the location and the physical activity. This is more or less the main components of the architecture. On the dependent side, we provide them with a bracelet. On the families, the professionals, the carers, we provide them with a gateway or with an application to be installed into their smartphones. In the middle, we have the cloud, where all the information goes. And there we have the data analytics, data mining, and all the processing. And on the family side, we provide a command and control center, just to know and to monitor their dependents. Let me show you an example. Imagine this scenario where we have two dependents, a child, a kid, and an elderly. And we also have two people, one, for instance, one policeman and one carer or family. Imagine that we provide the dependents with two bracelets. And we provide the professionals, the policeman and the carer, with the blue care application. And imagine that we install in the indoor environment and, for instance, in a playground, some gateways. Then the information from the dependents or the bracelet broadcast a code which identify each dependent. And this information also contains information about the physical activity, heart rate, temperature, and so on. I mean, all of this information that can be read by the sensors integrated in the bracelet. This information goes to the cloud through the different interfaces, depending on the coverage. So, of course, this solution mainly depends on the cooperation between the different devices. As much devices as these gateways and these applications we have, the larger the coverage. And once we have the information in the cloud, we can process all of this information, and after that, we can show the information to the families for them to take care about their dependents in general. Children, disabled people, cognitive impaired, and so on and so forth. Which are the main components of the system? Well, we have on the hardware base, we have the bracelets and the gateways. And on the software base, we have a mobile application and a command and control center. Just to show you exactly how they are, this is just for you to know more or less the size of these devices. This is the bracelet. In this case, these are the microprocessors which they integrate, and the different sensors. Well, the main functionalities is to broadcast the identification, an anti-loss signal, the activity, the heart rate and temperature, and so on. On the gateway side, well, the size is more or less like this item. And in this case, we integrate these two microprocessors just for it to have these two main interfaces, Wi-Fi, Bluetooth, and Zigbee. And we also provide the USB interface for programming and for charging the device. Well, here we need also a battery, of course. And the main functionalities is to act as an anchor gateway sniffer and can be configured in a local or remote way. On the software base, we have an application that can be also work as a gateway, but all the sensors are already integrated in the smartphone. So I think that it well, it doesn't mind. Just for you, if you want to, yeah, please could you click on the presentation just to go back. Yeah. Well, sorry. Yes, if you want to see how the website is developed, please just ask me, and I can show you in any of your laptops. So, summarizing, this solution is more than a simple application. It's a digital tool which take advantage of the Internet of Things, and as many devices under the blue atmosphere are connected the larger the coverage area within this solution could work. The main benefits of this solution is easy to deploy, it is cost efficient. They provide with a seamless positioning, of course, within the coverage area of these devices, and they provide with a secure environment in terms of they provide information of the families, relatives, carriers, and so on, to know where their dependents are and if they are safe or not. And it can provide you with the different parameters that can be measured by the sensors integrated in a current bracelets. So, well, that's all for me. Thank you for your attention.
Thank you very much, Alfonso. Do you have any questions in the audience? I will have one question to make you start. On your last slide, you talked about secure environment. Can you tell us a little bit more? How do you verify that this information and the data that you'll collect on the people that you are securing is relevant and accurate? And how do you guarantee, this is the first question, and how do you guarantee that it is the good user that you are scanning?
Yeah, this is a good point. Well, one of the first requirements for the development of this bracelet is that, well, when you install or when you give the bracelet to the dependent, there is an anti-lock signal. So when the dependent move the bracelet off, then a signal goes to the server just for you to know that that people has not the bracelet. So this is a warning for you to know that maybe that bracelet from that moment could be installed or could be placed in other people. So this is the first thing we take into account. And in terms of the secure environments, we are not talking about the cyber security and so on level, but we are talking about creating places where you are aware about the people who is inside, the people who depends on you. For instance, I don't know if most of you, but some of you have children, and I'm sure that you live a situation in which you are moving with your kids, and suddenly you, I don't know, attend some people, and suddenly, where is my kid? So, and these kind of solutions provide you into your mobile if the kid goes farther from you, I don't know, some meters, depending on the strength of the signal, or if they go into a place, a specific place or not. Of course, all of them depends on these gateways. If in this case, if the mall has this kind of gateways or not, or if the security people of the mall have installed in their smartphone this application. So
do we have any other questions in the audience? I have a third question then. What is the level of maturity of the solution Blue-K? Is it today something that is operational?
Yeah, it's operational, but it is a prototype. I mean, it's currently working. It's currently working in one hospital in Zamora. It's a province of Castilla y León in Spain, and it's also working in a big mall in Mega Park. It's in Bilbao. So we have two case studies on testing this system.
Which technologies do you implement in the bracelet?
Well, in the bracelet we have a microprocessor which have two interfaces: the Bluetooth Low Energy and Zigbee. And after that, well, depending on the application and the service, this is the minimum technology. And depending on the battery life, we can also install inertial sensors to estimate the activity of the user. We also can implement or integrate heart rate sensors and temperature sensors, and barometers also to know. The larger the information you have, the more parameters you can provide about the behavior of the user.
And in the gateway, you also use Wi-Fi? I suppose that you use Wi-Fi to connect to the network?
Yeah. The idea is between the bracelet and the gateway, we use the Bluetooth or Zigbee, depending on the gateway. And between the gateway and the cloud, we use mostly the Wi-Fi. But if we use the smartphone as the gateway, we can use the 4G or Wi-Fi or this kind of technologies.
Okay, thank you, Ramón. Thank you, Alfonso. Do you have any other questions from the audience? Yes? That's closest.
Hi, I'm Shrinal. Something like funny question, like if the battery gets drains in the bracelet, so how can you know?
Sorry?
If the battery in the bracelet gets drains, how can you know?
Yeah, we have a threshold under which if the battery is, I don't know, I mean, we always measure the battery life. So once the battery goes below 10%, we send a message to the cloud, so we know that, well, this is a warning. This bracelet is going to be lost because of the battery, so we need to replace, or we need to send a message to the family, to the carer, or to the professional who take care of that bracelet, dependent, just to remove or charge or whatever.
Cool.
Thank you. Do we have any other questions? What would be the next steps, Alfonso, of your project? What will be? So you said there were 2 prototypes running, one in a hospital and one in another environment. What would be the next steps of this project in terms of
at this time, we are stressing, I don't know if this is the right word, the system in terms of the connectivity, in terms of security also, because we are implementing the different protocols. I mean, also, depending on the microprocessor that you install in the gateway, you can implement more robust or not so robust protocols in terms of security. So the next level is to spread the word and to test these systems in more environments. But our aim at this stage, as a research center, is to finish our work in a prototype with a technology readiness level around 5, 6, 7, depending on the. But the next step will be to create, if we succeed, a spin-off or someone who wants to make business of this solution.
So if we have a town that would be ready to test your system as a smart city,
yeah, we can
we'll take it, because Angers is a smart city today.
Well, we
so
can,
why not?
Yeah,
try and implement it.
Yeah,
okay.
for sure. For sure. We are more than happy to test this solution in any environment.
Yeah. So Michel, you heard the message. Thank you very much. Do you have any other questions? Perfect. Thank you very much, Alfonso.
Thank you.
Now I have the pleasure to welcome one of our, going a little bit too fast, excuse me, one of our local experts in the field, Gregory Lidin, is joining us. He comes from a major company of the area, which is called Eolane, and he is an electronic engineer and is working in the design center management, and he will give us a presentation on his different approaches of securing IoT today. Is that it?
Yes,
perfect.
exactly.
Thank you very much, Gregory.
So, in fact, Eolane is a design center and an industrializator for any project like this one, the project you have. If you want to come from prototype to the industrial product, you can come to us. So we are first of all manufacturing products for our clients. So let's say you have just some components to put on the PCB, and you produce the product, you put in their casing, and that's all. Then we are also designing parts of those, a part of those products. Designing means the client comes with some prototype, for instance, and we find the best solution to bring the prototype to the industrial products with the issue of security design, but also production, how to bring a product to the production. And we have also managing design for our own brand. We have some own product for under our own brand. So we are not research center. Research center means we are not trying to find new solution. We are trying to find solutions that are at the industrial level. That's very important to understand. So we are integrating already existing solutions. And we are looking for solution going to the market today. That's very important for us, and you will see why. So, just a quick understanding about what we put on the market. We start from kind of starter kits, house starter kits or starter kit from the market. We don't care. We built some gateways on several networks like Wi-Fi, Li-Fi. Also, we manage it. Of course, LoRa, Sigfox, etc. Then we had developed some end nodes. So what I present here is only products under our own IP, because products that are on the IP of clients, we have not the right to present. And then we operate also a SaaS solution to make a vertical solution, means to add service on the network of sensors. So what I will speak about is the issue we face with designing custom products for our clients. A client like you come with your project, and we have to take into account the security issue as a part of the design constraints. And most of the time, every client comes with another case, and we have to find some easy solution, safe solution to implement and to industrialize the product. So, in general, the IoT, that's a very general understanding. It's the interface between the IT world, where you have big resources for computation, where you can do cryptography, VPN, handle VPN, you have big data servers. And on the other side, you have the device world. That's not mine. Of course, it's mine. Okay, sorry. The device world, where you have small footprints, low power, low bitrate, and in general, you are running on MCU, so microcontroller. And according to the clients, so the guy, he comes from here, and he comes from the world of IT, and he wants to have a sensor that fits to his world. Or in the opposite, you have a guy who comes from the small footprint system, and he wants to connect it to the IT world. And our issue is to make it this vertical safe. And of course, we speak about the diversity of constraints in the IoT. So I spoke already about autonomy, footprint, so it means mechanical, computation, memory, the reactivity also. It depends on the use case, but if you have not to wait 10 days to find your lost kid. Network capacity, price, and time to market. Price and time to market, it's the big deal for startup. You have startup coming with a good idea, it works as a prototype, and then you say that you need 500,000 euro to bring it to the market, and the dream stops here. Tank. So the time to market, and of course we have the issue with the security issue that comes on that as a new constraint. So that's going too fast. So in the past, we were we had to make a compromise between cost and risk. The risk, I speak about the risk for security. Security, I don't speak about safety, I speak about security of the system, means the fact that it's protected against violation, against replay, against data corruption, etc. However, today, as the sensors, the end nodes are multiplied, we have no way, we have no choice to run a new such compromise. Such compromise are dangerous, in fact. Even with systems where data are seen as non-sensitive data. If you have a sensor with non-sensitive data, you may be hacked also, and it makes damage or collateral damages, or it makes publicity for the hacker. So, in fact, the security is an issue even for a non-critical system or non-sensitive system. You have to raise temperature from a place every day and from 1,000 places or 100,000 places. If somebody brings some wrong signals into your measurements, it breaks your system, and the costs is very heavy. So the security is in fact no more a compromise with IoT. As manufacturer, so Eolane as a manufacturer, so we design the product and we bring it to the factory and we deliver it to the business or to the customer. So we have other issues, and one of those is the management, the logistic of the secret, the private key. That's an issue. In fact, we are the fact to write a private key into a product is something that is potentially a risk. We have also some issue with hardware buying and MOQ, minimum order quantity. If you buy some components, today in the future IoT will be hundreds of thousands of sensors. Today it's more thousands, hundreds, thousands, 10,000 sometimes. It's not yet the big deployments. So we have to buy components with security features for small quantities. That's a difficulty, because the market, it's not yet completely set up. And in fact, so the MOQ, the minimum order quantity, is an issue. Then, during the life of the product, to survey the software security is an issue also. And we have to care about the standardization of solution, because we have to reduce the cost of maintenance. If we develop one system for one client and then another system or other solution for another client, it's a mess for the maintenance. And so, of course, also to think about the case of the private key is broken, and that we should renew it. How to handle this? So the security should be considered end to end. It's an issue from the sensor to the cloud, and we should consider it not only on the sensor itself. We should not consider the sensor or the end node or the device as secure as itself, but we should consider the complete vertical solution. We think about the architecture distribution and also the data flow and the data location and storage, where to store, where is it safe to store some sensitive data, where not to keep sensitive data. And we spoke about that, about 2G, 3G, or LoRa Sigfox. Network security mechanism may not be so safe, and we need to secure it on a upper layer. so an applicative layer. For instance, HTTPS is something that is reliable between 2 points, but if we want to consider the security of the entire system, we will make some security cryptography from the end node to the back end. That's why in our design center we have some design methodology. We apply some design methodology to design new devices, thinking end-to-end, so it means from the fleet of devices to the servers. And we have made a selection of technology on we can rely. So let's speak about methodology. It's really I don't speak about technology only, because technology only it's quite dangerous. You will see that in fact the security issue is not only a technology; it's also a way to design, and also team training, team understanding of what is security. Methodology. So the software management plan is the place where we define how we will handle the security in the project. It's a derivative of the project management plan, but we speak about software and we speak about security and how to secure how to secure during the development, after deployments, and during the whole life cycle of the product. So this is a topic we handle at the beginning of the project. It's of course it's a template because it's an aggregation of good practice, and it's understandable by each developers or each team member in our team. Then we have to understand also the security requirements at device specification level. In fact, so we have two kinds of clients: those who comes with no needs about security, no needs, nothing is defined. And in fact, they have the understanding that the security is not an issue. And on the other side, you have guys who want the best, the biggest system, the much security is the best it is. And most of the time, they come from the IT, so they are expecting some VPN solution, for instance, on small connected devices, and this is quite difficult to handle on our microcontroller. So we perform a risk analysis, like we do a risk analysis for field events for safety, but that's for security. And of course, we master the risk analysis through the architecture, and we put in front of each risk a solution, or let's say we raise to the client a gap for security, because we don't build a perfect iron box around the system. We can also say that some security issues still are open, and that's a risk the client or we take. And finally, we do a final qualification of the solution by an autonomous or external team. So this is a bit the concept of external hacker who comes and to try to perforate the system. And this is something that is that brings a report, and it should go in front of our first risk analysis, and we try to understand the gap between what the report and our first initial analysis. The entire methodology is a derivative from the French EBIOS directive. So this is something, it comes from the IT world, and we took it to the IoT embedded systems. It's good practice to analyze each risk from the human factor to technological factor. And it gives us a framework, let's say, that makes us confident about the way we deploy our security process. So that's about methodology. Then, of course, on the technical side, we have very basic rules to observe, but so basic and so it's so strange. You spoke about the car that has been hacked recently. In fact, we have studied that case. That's a scholar study for my team to understand exactly the path used by the hacker. And in fact, it's really open door. They just use open door. So to close all physical access, like alternate bootstrap, native bootloader, etc., you have to burn the fuse not to let the door open. We are using intensively and systematically on any system. It's IoT, very tiny systems to M2M, PC-like systems, edge systems. We are using a secured element. That's a digital safe box. I will speak about that just later. To store keys, to perform the cryptographic computation, and to store also sensitive data. The thing that what is interesting is that the private keys are not handled by files or on the network. The private keys are stored into the component in our device, and by a professional cloud handled as a high security level system. And so the private key never goes out of in the nature. So let's say this is an integrated solution. It's a silicium system. And for us, it's the easiest way to make a system safe and to avoid any risk for cryptography, for update of cryptographic computation, or to have some issue with the keys or the certificates. Furthermore, it's protected against case opening, thermal analysis, and that's also good for us. So it costs quite nothing. It's inside the hardware. Of course, you have to go through the component, which is a communication frame, and that's all. Then, on the software side, we have to master the bootloader, or the capacity of the system to make our software update. And for that, we use the chained authentication of the software. And that's a native system from the microcontroller or processor to make that each bootloader and then applicative layer program are chained together through a certificate, and that's you cannot corrupt, so you cannot exchange one software. That's also something that is now used in the cars, and so that's industrial solution. Of course, the team has to make survey or oversight of the technology. It means we have, as we guarantee our products about security attacks, we need to understand the world of hacking, to understand the new technology and the new products, and to upgrade them frequently. And of course, we bring security updates via over-the-air programming. So the fleet management after deployment, if possible, if the technology, let's say, if you are on LoRa, it's more difficult to update the product. But if we are on other networks, it's possible to send on the fleet some updates and security updates to maintain the fleet. And the last point of attention is the human factor. In fact, it's something quite difficult to manage. We speak always about technology, about very complex computation key algorithm. It's a very good safe box, but then the first factor of risk is the man. It's not on purpose. It's maybe not on purpose, but we need to train our team about the sensitiveness of the system, why it is important to keep the secret about the way it is designed, even if so you know it's the first factor to understand how something works. It's to read a CV. Huh? Curriculum vitae is very great to understand to survey the technology of other companies. So that's something that should be handled in parallel with technology. Of course, on Linux especially, not to keep default password and to close ports, etc. It's something stupid, but we have to check that. So to check that, it's cross reviews. Never one developer alone on one system. We have to exchange the rules, and so one developer, one validator, one tester, and they exchange the rules, and we check that. We cross-check the work, and we have a checklist for security. Then to understand, to make the team aware about the process of production release, it means you are working with an open software, unprotected software during the development, and suddenly you come to the market and you have to lock the software and to make it safe. So that's a process, and a serious process that is, let's say, that takes some days. We do it on purpose. It takes some days to say we go on production and we are in production. It's 5 days. And to avoid any mistake, because then if you send a software over the air on a fleet of devices and it's wrong, it's the certificate is wrong, etc., it's a big problem. So production release process, and to make that it's strong, and to master handling of the keys. I spoke about that earlier. In fact, the best is not to master by hand some private keys. And so with the secured elements, no question, it's not going through our developers or through our factory. It's in the safe box during the entire project. So I think it's finished, yes. So that's it. I hope it was clear about our activity.
Thank you very much, Gregory. Do we have any questions? I would have one question, please, Gregory. Could you give us an example, a concrete example, where you have applied this whole methodology in industry, something that is quite common for Eolane today, and tell us where you have spotted, for example, security issues and how you solve them. So,
yes, I have 2 examples here. The first is for Carrefour. It's a product for the end user. It's the Pickit product. It's a kind of scanner for consumer scanner for to build your drive shopping list. Yes, and this is the first case I spoke about. It is the interface between IT world and embedded systems. Here we have a first the requirements were very basic. It was 3 lines. It said 3 months of battery on one battery without charging, safe, secure. What does it mean? We don't know. Secure, and then it should speak and scan. Blah, blah. That's all. Then we have to take that, and of course the guys we have in front of us by Carrefour are IT guys, from server, from Java, from the life of the big data, and etc. So they are themselves managing a fleet of computers, and that's all. And so for them, that's a computer, and that's the point. So and then it should cost some euros, and so you are not able to put a microprocessor inside it, and then you have to find a good solution. So it's really difficult to make. So the price is very low, no energy consumption. Of course, the product should react in real time against the preemption, and then for scanning, you have not to wait 10 minutes that it speaks about with the to get a certificate to speak blah blah blah, and that's the issue. That's one point, and then the other, it's our LoRa sensor, and the LoRa sensor is we introduced the secured element from the beginning to avoid any discussion about security. And that's, in fact, it's for us, like not like scientists, but like integrator, is the best solution to avoid any discussion. And it makes that the encryption overlay the LoRa protocols. So applicative data are encrypted into the frames of LoRa, and then you can decrypt them where you want. So the higher you want. And that makes that it's super clean, super safe. So here we have two examples. Here we were master of the design from end to end, and we choose the best solution, the more efficient also in terms of cost. Here we spend months and months to fit the software inside a very small microcontroller.
Okay, thank you. Do you have any other questions? You are all a little bit knocked out. Is it too hot in the lecture theatre, probably? I have another question. It's quite surprising and not surprising at the same time. In the network environment, because you said you gave an example on the other side, the technical people who are in front of you are more IT profiles, so for them they considered the sensor as a computer. And you have highlighted that one of the main issues, even in securing Internet of Things, is the human aspect, which is today something that is very well known in the computer environment, because it's always the human that makes the error, that makes that your computer will not, or the network will fall down, or they're going to click on this, they're going to put their password somewhere, and things like that. It's very surprising to see that even in Internet of Things, it's the human factor that is also one of the challenges. It's not surprising for me, but could you highlight some examples of how a human can make a major mistake?
In fact, the major mistake is on the design side. It's possible, for instance, to rely on the fact that LoRa protocol is already crypted by the network, and to say that it's enough. And so that's why we apply a very dry, unfriendly method to understand that it's maybe better to add one layer of encryption. That's it. So, in fact, the human factor is something, let's say, nocive or not nocive. But let's say nobody is nocive in my team, I hope. But it's just because the pressure of the project, you are not aware about everything. That's why we have a very boring process to qualify the security. And the process is the same deployed in the IT world, but we consider the end node a part of the complete system. That's all.
Okay, thank you. Do we have other questions? No, still not. So I'm going to continue because I took a lot of coffee. I have one quick question. I would like to highlight an approach that I talked about at the beginning of our presentation, when you give your system to an outside company to try and hack it. Can you tell us a little bit more? Is this systematic? Is this done every time when you inject a solution on the market? Before injecting it on the market, you have an outside team that tries and hack it and delivers you an element, or is it for specific projects?
It's recommended by the client. So he asked that because it's expensive, in fact. You have to spend time. More time you spend on the system, the more you have chance to break it. So
it's more an order from your customer who's going to say, I would like you to give me an audit and hack it. Okay. Do you have an example to give us that something that has already been hacked or tried to be hacked in the solutions that Eolane provides?
No, but I have an example about car systems, because I was developer in the car field. And in fact, I was working as developer, so I can speak about me for mistakes. It's okay. I was a software developer and developing just some bootloader and startup systems for cars, for a brand, famous brand. It's not a problem of German, French, we don't care. And in fact, I was super sure about my own developments. It's a 2-year work, it was crazy. And in fact, we gave it to a validation team, an external, and the guys get some bonus if they break the system. Of course, they were really motivated, and they broke it. And so this was the beginning of my career, and I understood that it's difficult to rely on one guy for such design. That's all. But even if you are good or bad, let's try. If you say that it's safe, let's try by somebody else, and let's see. And in fact, my issue, my bug, was really the way to enter in the system was very easy, very, very easy.
Which is often the case.
I cannot speak about that, but it's so easy.
Okay, thank you very much. Do you have any other questions? So that's probably why you apply the cross-view on development.
Yeah, absolutely. In fact, we get inspired from the safety development, so from automotive processes to security.
Okay,
that's it.
Okay, thank you very much, Gregory. Thank you. We are getting almost to end, but we are going to finish the last but not least. I'm calling Waldemar Graniszewski, who is an assistant professor at the Faculty of Engineering of the University of Warsaw, for a presentation on the current threats and challenges in cybersecurity. Thank you, Waldemar, and have a nice presentation.
Mr. Chairman, ladies and gentlemen, first of all, thank you for this invitation to this symposium. I'm really very glad to have the presentation today to you. And I think one of the greatest challenge for me today will be to wake you up, because there's the last presentation, and the second one, which is, I think, also not so easy. That actually I have over 1 hour for my presentation, according to the schedule. Okay. So I don't know if it is good or bad news for you, but I try to do my best. Okay. First of all, as it has been told, I am the faculty member of the Faculty of Electrical Engineering, and as a research field and the teaching field, I am somewhere in the middle about the topics which have been already mentioned. Okay, so about IT, automatic control, and robotics, and also electrical engineering. Okay, and as I told, having a little bit experience with teaching students, I think it's good time to make some quiz for you, which I think should help you wake up, and perhaps you can help me to find the solution for these 3 key figures which are mentioned here on this picture. The first one. Yeah, thank you very much. Very good. I have no, I have no present to give, but if I had, yeah, very good. The second one. I haven't heard. Yeah, exactly. So actually, the number of faculty members at our university, so Warsaw University of Technology. The third one. But sorry, I'm not sure because I've heard some voices. If you can speak louder a little bit. The second key figure, 20. Okay, so I win this. Yeah, you are right. Yeah, it's this number of faculties which you have got. So there's plenty of faculties, as you can see. And last question, which is not mentioned. What do you think? What is this room here? It's our main hall of the Warsaw University of Technology. Okay, thank you for your attention. And now I'd like to skip to my presentation. something goes wrong. So actually, you have seen my old presentation, so I don't need to. Probably it has been hacked. It seems that it doesn't work, you see? Definitely, it has been hacked by someone, I don't know, but not myself. It's okay. Okay. One second. Axel, if I may ask you just to come to the second slide, okay? I think this is the most important slide in this presentation, okay? The other you have heard from other speakers, and actually you have already seen these slides. So first of all, I would like to make short introduction to the field of the cybersecurity, about selected threats and the selected challenges. Then, as you can see, a few words about IoT, so Internet of Things security. And then at the end of the presentation, I would like to draw some conclusion, okay? I think the first, probably, actually all was already said by my by previous presenters, but probably you are wondering why actually we call it cybersecurity. Actually, why actually we are talking not about the security of the internet, information and communication systems? Okay, so probably you will not find when you go back to some sources in the 1980s or 1990s, you will not find the word cybersecurity, okay? Instead of that, you can find some guidelines like Orange Book, okay? Some guidelines like norm, which is already mentioned by my previous speaker, which is the norm of the ISO 27000 and the other norms. Okay, so there are some guidelines, and actually, I think it's quite difficult to precisely define this field. So cybersecurity actually is quite a lot of things to mention. Today, I just wanted to focus on some security threats which are probably important, not only from the point of view of the private user, okay, but also from the companies. Probably you have heard about some threats which are mentioned about the ransomware. Okay, starting from the 1990s, probably the most of the threats were connected with floppy disk. Okay, because you could just bring this floppy from one device to another. Okay, then in the 1990s, as you probably know or remember for some professors, the internet was implemented, okay, and was actually the one of the way where we are now happy. I can check our Facebook account, our Twitter account, then can mail other person. But of course, it's also the security issue for possible private person, business, and also the Internet of Things field, okay. And one of them could be ransomware, which is, of course, just one example, okay? One example, but very, I would say, very important because of the costs which it can bring to the person or to the business. So when all your important data is encrypted by someone who wants to then ransom from you, you're probably not very happy, okay? When it is company, it can break the business of this company because all important data, especially data about the customers, and if these customers are, for example, patients, oh, it's a very pity, okay? So just imagine this, that it could be one of the most important issues currently because as it has been mentioned by Gregor, now we are connected to the internet, okay? So it means one of the weakest point of this system is human being, okay? Not only one, but one of the most important things. So we get hundreds of emails daily or in a week So we have to country choose which one is important and which one we should read, or even which of the links we should follow. Okay, I don't go too deeply to the details. Of course, you can find this on the internet. You can find the explanations, so on how to avoid risks, how to be more secure. Okay, because I have to stress it once again. In my opinion, and I think it's not only my opinion, the one secure computer system, information system, is system which is unplugged from the network. Okay, and the second, I think, which is unplugged from the power. Okay, it should be more secure than this plug. But of course, no one would like to have his or her mobile phone unplugged. Okay, so you could see that we are looking for a supply, energy supply, if we want to be connected. Okay, so just just would like to switch to another factor. I don't know. Probably you know this man, which is quite familiar for being I would say the flag person about the open source systems, operating system, and so on. I would say in our current operating systems, there are a lot of features which are not in my point of view, but in point of view of Richard Stallman, which, as you can see, gave the speech in France 3 years ago. And our operating systems have other features which should help us from one hand side, and from another hand side have some drawbacks, or in my opinion, not necessary features, which could tend to be malicious. Okay, I think it's a good idea, for example, to update our systems, embedded systems, but sometimes it can also bring a risk to the users if they cannot control their own systems. Okay, just think about your mobile phones and about tracking of your location, about suggesting your buying when you research internet. Okay, from one hand side is, I would say, positive in the meaning that you can find things which are really important and necessary for you. For another factor, I would say that could be dangerous, because if someone will keep this data, what can he or she or company do with this data? Okay, this is a question of ethics and other things. Okay, I think actually all was said about the Internet of Things. Actually, I have not to explain what does it actually mean and what is the idea of the Internet of Things. I think, as usual, the main idea is very important, and I think should help the human being to do more efficient their jobs and so on. So we can actually connect. We would like to be connected. We would like to have what is the temperature at our home, what are the settings of our air condition, what are settings of our heating, and so on. This is the good news, of course. But the current and previous threats which are discovered, okay, I think should encourage us to think about some possible issues, some threats which are behind. Okay, so I just named here as previous was mentioned, one of the last discoveries, which are perhaps not so especially difficult to avoid. So I would say the problem with the WPA2, which can lead to discovery and to break the communication and install or deliver the money in the middle attack. Okay, but you had also some issues with another another communication protocols, like Bluetooth, okay? And when we think about the Internet of Things, I would say that one of the, perhaps, more secure than other technologies would be fiber optics, which was mentioned by the second speaker, okay? Because we can make it more secure. But when we connect all devices in wireless technology, I would say it's the same as the first Ethernet technology, that we are in the bus topology, so everyone who is in the same area of signal can eavesdrop this signal, okay? If it is possible to decipher, it's always a question of protocols, okay? So just think about this, and as I told, perhaps my slides are not very informative. You cannot find here the, with the exception of the first or the second slide, where there some figures. But think about the norm and other things which you can fulfill developing your system. I'm really glad hearing that in the car industry and also in the company mentioned by Gregor, they implemented this norm 27,000 from ISO, because as I told, it's guideline for the all actual operating systems and ICT technology. Okay, if you fulfill this guideline, probably you will do your best to developing the safer systems. And just in the middle of my presentation, I decided to show you an video. Please follow this link if you find it on the internet.
This is a little toe tapper for all you kids at home. It's all about connections. The laptop's connected to the smartphone. The smartphone's connected to the tablet. The tablet's connected to a button. The button's connected to a taxi's connected to your mailbox, your mailbox connected to a letterbox. The letterbox connected to your friend's phone phone's connected to a mom's phone, your mom's phone's connected to a jogging shoe. Connected to a wristband, the wristband's connected to a popcorn stand, the popcorn stand's connected to an escalator. The escalator's connected to an ice hatch, the ice hatch's connected to a TV set, and everything's connected to a super Kit Kat.
Just because it's connected doesn't mean it's smart.
Okay, I have also the second video, but I don't want to waste your time. If you just make a picture of the slide, and please follow this link. If there will be enough time at the end of my presentation, I will show you also the second one. But I think it should help us to think about the problem, not to discourage us to perhaps make our life and our researches and our studies easier. Okay. Okay. Now I'd like to switch to another important factor which could help us and could bring to our private life and our security a little bit ideas and other factors. This is the General Data Protection Regulation, which should be enter in the May next year. Okay, so every private companies which use the data of the European Union citizens should keep these rules, with exceptions of the, I would say, state companies or state administration, which is not included in this regulation. Okay. According this regulation, our data should be protected in such a way that, in the case of any security issues, it should be not broken. Okay, so the rules could be not broken. What does it mean actually? It's a relative huge fine for the not complying with this regulation, because the companies should pay 4% of their worldwide turnover, which means about the highest fine should be about 10 million euros. Okay, so in the companies, relative small companies, it could be probably the last day in their life. Okay, so there are some guidelines and other factors which, from one hand side, should secure our data, especially our sensitive data, which one of them could be our IP address. Okay, IP address of our mobile phone, other things. Okay, so just to give you the ideas, another factor could be, as I have already told, that companies who want to, or not want, they have to fulfill these requirements fully. It means they have to implement some guideline, like this norm mentioned already, ISO 27000, or another. If there's the company which deals with the patient's data, they also should, I would say, keep this data safe. Okay. Okay, and probably you would like, and probably you ask me, what should I do actually? Okay, it depends of the point of view, and it depends on your personal situation. I would say, if you are a private user, probably you need to patch your own system. Okay, but if you are CEO of the company, probably you have to implement one of the system, one of the intrusion detection system or other systems, which should help you to protect your data, which should protect your systems. Okay, but of course, this is one of the solutions. But another important factor could be, and should be, and actually I think we are here all together, that to prepare for the cybersecurity, actually, you have to study a lot. Okay. This good and bad information, actually, okay? Because it means you have to spend your time sitting in the front of a computer, programming, testing, developing. And perhaps 3 or 4 years is not enough. You should learn all life, okay? And so I do, actually, okay? Therefore, I'm here. I'm very, very glad to hear from the other speakers that some issues could be potentially avoid doing in their jobs. Okay. So just to sum up my presentation, I just only presented selected aspects of the cybersecurity. Okay. You can find more in the white papers, and you can find more in other sources. Okay, I just mentioned few aspects of the IoT security. Okay, and finally, I'd like to stress that its challenges for the cybersecurity could be, first of all, good education for the people, not only the ICT experts, okay, but also for the quite, I would say, end users, which have their own mobile phones, have their own computers, had their own IoT structure, okay, infrastructure. This is, I would say, one of the main challenges. Thank you for your attention.
Thank you very much. Do you have any questions? Yes.
Good afternoon to everybody. My name is Prakash. I'm doing my master's in ESAIP. Sir, my question to you will be, can machine learning be a breakthrough for cybersecurity?
So actually, the history of the machine learning, it's not so, I would say, young as we think about it, okay? Because as you probably have read or have heard, the idea of the helping us with solving some solutions is as old as the computer systems, okay? So in the 1950s, have already started some kind of the ideas how to think about how to use the machine, I would say, our computers like our human beings, so starting with the developing of the idea of the neural networks, okay? So it was improved through the, I would say, decades. And one of the big problems in the past was the computation power of the computers, okay? Now, currently, our mobile devices have enough computation power to do many tasks, okay? So from one hand side, of course, we can use the computational intelligence, or as you told, machine learning, or if someone tell different artificial intelligence to discover, just to help the anomaly detection first of all, okay? We can, of course, implement it in our software, in our embedded software, just to help us to discover anomaly situation. It's one of thing. We can, of course, implement it, and it has been already done in different intrusion detection systems, intrusion prevention systems, and in different firewalls and so on, okay? So actually, it's already done. The question is, of course, if it is efficient enough now to find the so-called problems like zero-date exploit, okay, which is not known for everyone, okay. But if your project, for example, the business project is, I would say, important enough to try to do some exploration of some company environment, perhaps it can happen, okay. I don't know if I answer your question.
Okay.
Thank you.
Okay, thank you. Do you have any other questions? Yes.
Thank you. I'm Jan Debly from ESEO. What place would there be for ethical hacking in cybersecurity for the next years?
Sorry, I didn't catch your whole question. I just had ethical hacking and next years. If you could repeat your question.
What would be the place for ethical hacking in cybersecurity for the next years?
Mm-hmm. This is a very good question. I think the answer should be, it depends of the regulations, okay? For example, in Poland, where I am from, also the ethical hacking is prohibited, okay? So it means if you want to just show the company that their systems are prone for some incidents, okay? it's prohibited, for example, in this case. I don't know what is the rule in the France, I must admit. Pardon?
I can give some answers.
Okay, thank you very much.
Yeah.
Thank you for helping.
Okay.
Yeah.
Just quickly regarding ethical hacking, if you had asked this question 10 years ago, I would say it would not exist here in France, meaning that, in fact, it was not allowed, and when it was done, it was hidden. There is a real movement in a society where the people can notice that it is probably one of the best ways to secure a system is to hack it. So today, even the French government, army, police, and everything are training their staff members in ethical hacking. So I would say it was at the first international forum of cybersecurity I've attended, it was not allowed to talk about that, even to talk about it, even though some of these police officers and army specialists would come and be hidden in the graduate schools that were doing ethical hacking to teach that. Today, it is totally tolerated. It is even recommended, meaning that in France, I'm talking about, it has been for throughout the world, in numerous countries, it's already considered as an element. So I would recommend highly, if you are planning, as there is another graduate school of engineering, if you're planning to go to the cybersecurity environment, I would recommend personally to go through ethical hacking, that's for sure. This is an international standard, even though some countries don't want to talk about it because they just hear hacking, they don't hear ethical. But the limit can be sometimes a little bit complicated to see.
Thank you for this help with this answer for this question. Thank you very much.
Do you have any other questions? Please.
I'm Mohamed Miraj, I'm from Morocco. You asked one question about some properties of application of software is similar to ransomware. And when we have really proprietary software, how can we combine between both of them? Have an open application, open source application, to be the owner of this all the software, and to give to our customer proprietary solution. Both of them we can find some breaks about security. How can we combine between both of systems?
Thank you for this question. As far as understood, I'm not sure if I am able to answer this question. Okay, but because as you could see, Richard Stallman, which is the I would say great opponent of the I would say proprietary systems, because one of the I'm not his proxy. Okay, so. But just to tell his words, he thinks that if something is closed, we don't know what is inside, so actually what it can bring to us and so on. And from this point of view, I think it's a good idea, but probably I wonder who would be able to go through the all source code of, I would say, operating system, okay? Probably it's very difficult, even for the experts, just to analyze the all lines. Probably it's very difficult, but this is one of the idea that if something is open, so it's not, you can check and you can check the source code. Probably you will not find the, I would say, backdoors. Okay. From another another point of view, from the companies who deliver us the systems, of course, there is the responsibility for, I would say, security of those systems. Okay. But I don't know. Probably you have heard, and of course this is just the idea of to debate about our operating systems, also about our our security systems like virus detection systems. Okay, there's always the question if there's any backdoor in those systems or not, or if this, I would say, important for me. And if it can break my privacy and so on, okay? I would say I can't answer this question. It's very difficult. I would say we can debate the whole evening here or even more longer, and I would say it's quite difficult to answer. Okay.
Yeah. Some reputed editor of construction give some software like Intel with resident program for support purpose or for support maintenance. We can remotely access to this kind of appliance. But this is a bridge for us.
Yeah.
We cannot give our server, our financial server, to be accessed by. We don't know who can
exactly. Thank you for this comment. I just try to I would say repeat your question. So this is the question: if you want to install antivirus software, for example, and this was the, I would say, relative huge debate between experts. If, for example, Kaspersky antivirus software, which was installed and is installed probably on very platform proprietary platforms, is, I would say, kind of backdoor for three-letter agency in the Soviet Union. And the question is, if the other vendors of the antivirus software are not the, I would say, are not selling the information or giving the information for another state agency, three-letter state agency. Okay, this is a question how to deal with them. I don't know actually. You wanted to add something?
Not bringing answers, but I would like to give also a view on proprietary software, because we are developing, we are selling proprietary software, and we deliver it as source code. So it can be reviewed, it can be checked, it is documented, but it's still proprietary. And in fact, with our customers, it's more a question of trust. Of course, in this world, who can trust another one? But we give them efficiencies. They can be quick on the market. They can develop their feature based on our operating system. It's delivered as source code. If they have the energy to do it, they could review this source code as they would do. They can also do with open source code, but they don't. And our reputation in the market is based also on the quality and the independence of our company and the serious of the tests we do. But at the end, it's a question of trust.
Thank you for this comment. I think, from my perspective, I think it's also very important. For example, if companies, especially military companies, sell some missile systems, for example, okay. And it was a great debate. I don't know, that is the quite fragile environment, which I want to point out. When there are agreements between governments to sell this missile systems, for example, and when there is, I would say, closed proprietary system, we don't know if we can deactivate, for example, this system. Okay, this is the question: if we trust or not. Okay, the same with for example, medical systems. If we trust that someone will not, I would say, inject to us more medicament, which just kill us. Thank you very much.
Okay, thank you. Do we have any other questions? Didier.
Hello, I am Didier Ginestou, Network and Cybersecurity teacher. I think that with IoT, we will be able to secure the data, maybe, but not the people, because of the traceability and the overlapping of the data. What is your opinion?
So as I told before, as you could see on this movie, which should entertain you, because these things are connected, then it's very difficult to, I would say, to secure the data flow. Okay, which means there is always three factors: costs, quality, and scope. Yeah, and actually you can reach both. You can reach only two of them. Okay. So it means if you want to be fully secure, probably you have to invest a lot of money, and it's not proved that you'll be secure enough. So it means when there are devices are connected with each other, probably one of the good solutions could be to install VPN on both sides. Okay, so it means on the end user device, on the end measurement point, okay, and then to all data sent as encrypted data. But probably these devices will not cost below €1, okay, and this is the question of costs probably, yeah. And I think it's difficult, of course. We can secure data. This not, but as I told, we don't know the weak points which we have not discovered yet. Okay, which usually the hackers are one step behind us. Okay, then we try to follow and to patch our systems and our technology. Okay, I don't know if I answered your question.
Okay, thank you. Do we have any other questions? Yes.
So it's not exactly a question, but it's a remark about your presentation. I think it's very interesting that you spoke about ethical not only for ethical hacking, but also about consumer education, and I think by extension for the ethical for product design for engineers, for students engineers. I think it's important to understand also what is the purpose of IoT. And even if you continue to live as engineer and to develop some products, I think the topic of so ethical when you create a sensor or an end node is very important because in fact, so the IoT is the extension. It's a sensor to feed the cloud, to feed the GAFA people, so what you want, but from data from the real world. And I think it's very important as an engineer to understand the final purpose, the business behind IoT. And you have introduced that topic, and I think it's important to go let's say behind the technology and to speak about what is the purpose of that. Then to be aware about that, and then to continue to live and to develop, etc. But to be aware about that. So I want to thank you for that.
Thank you for this comment. If I may just sum up, because there are a lot of words told. Actually, on the second link which I showed you, when you can follow on the internet, it is told the problem why actually you should take care about our devices which we usually use and which have more and more, I would say, intelligent systems on board. Okay, there is an example of a fridge, okay, which you used for over 70 years. Actually, my fridge is also actually equal 70 years old. Sorry, 17 years old. I'm not so old, as you can see. So I just would like to give another example, okay? Because then you can watch, and then you can think about it. But think about cars, for example, okay? Actually, I'm not so rich, but I've got 2 cars, okay? Because of different reasons, I will explain it later during discussions. And one of them is relative, I would say, robust, which is about exactly 20 years old, okay? I'm almost fully dedicated to this car. So for this reason, I will not sell it in the nearest future. And if something went wrong, I am able to repair it. Okay. Still, I have got also another car, which is I would say younger, about 3 years old. Okay, and I would say probably I would be unable to repair this car. Okay. Although I tried to do some, I would say, improvement when it was necessary, I would be unable to secure my car. Okay, I would really afraid if someone will break my, I would say, computer system, my car, and not just stealing my car because I have insurance. Okay, but just to think if someone just for fun make something difficult for your car, but for those who had children, I just encourage you to think what's happened if someone would like to follow your children, having just data from some of the network which collect this data about I would say precise position of your family, your car, and other things. Okay. Thank you. I think just
thank you. Thank you very much. I will just add before we conclude a comment and a question for all of you, the same elements. Just the first comment is that I'm very happy to hear certain elements. I heard trust, I heard digital, I heard a very good comment of Eolane saying when you develop something you must think about what it's going to be used for, because you must take that into account to adapt the technologies you are going to use. Internet of Things, cybersecurity, databasing, everything that is related today generates in the public environment a lot of stress. The people are worried. They're getting more and more connected, and they are seeing that more and more the customer or the content, it's themselves, and there is a real risk.